when we differentiate a term like y equals so many x to the power of n, we differentiate the y equation with respect to a variable, with respect, in this case, to x. And when we differentiate it, we say dy by dx. That's how we say it has been differentiated. So we're differentiating the y equation with respect to the letter x. So what we do is we take any power of the letter x and we multiply through by that power. And then we reduce the power by 1. So here the power is n, so it's cn times x. And then we reduce the power by 1. So as we said here, the rule in words, to differentiate, we multiply the coefficient by the power and subtract 1 from the power. So let's see how that works out in a couple of questions here. So here we have y equals 4x cubed plus 2x squared minus 7x. So when we differentiate the y equation with respect to x, it means all the x terms are going to change. So look at the first term, 4x cubed. Well, if I take the power of x and multiply through by 3, I get 12x. And then I reduce the power by 1, so 12x squared. Same thing with the second one. The x has a power of 2, so multiply through by 2 to get 4x and reduce the power by 1. So it's plus 4x. And x to the power of 1, we don't write, we just write x. Same sort of thing here. Actually, this is x to the power of 1. Well, 1 times anything is just itself. So we get minus 7. And then we get x to the power of 0. But anything to the power of 0 is 1. So we don't actually write x to the power of 0, we just leave it as minus 7. And likewise, we could write 2 as 2 times x to the power of 0. But then when we multiply through by 0, we get nothing. So anytime we have a constant on its own and we differentiate it, it becomes 0. Anytime we have an x term on its own and we differentiate it, we're just left with the coefficient in front of it. Second example. This time we have slightly different notation. We have f of x. And what we do just for f of x, we just write f dashed of x. And that signifies that we're differentiating it. It's in terms of x, so we're differentiating the f of x with respect to x. So again, look at the power of x here, it's 3. So multiply through by 3, 21, and x, reduce the power by 1, x squared. And 3x squared, well, multiply through by the power, we get 3 2s are 6, and reduce the power by 1, x to the power of 1, which is 6x. Minus 2x, we've seen that when I differentiate an x term, I'm just left with the constant. And just be careful with this next one. This is x to the power of minus 1. Well, we're going to go exactly the same way. When we multiply minus 1 by a minus, we get plus 1. And when we reduce the power by 1, we get x to the power of, be careful, negative 2. And finally, the third one here, or last one here, sorry, when I differentiate a constant on its own, I just get 0. Now these two are a wee bit harder, and they sort of relate to the previous example. Because y equals 1 over x, when we want to differentiate in terms of x, we need x to the power of something. So the first thing I need to do here, even before I differentiate, is change 1 over x into a power of x. And that means to the power of negative 1. Remember, the negative index means the reciprocal, 1 over. And now, because it's in index form, we can differentiate the y equation with respect to x, dy by dx. At minus 1 times 1 is just minus 1, and x to the power, reduce the power by 1 to the power of negative 2. Now, what I might like to do is, because the original question was in fraction form, I might like to put this in fraction form. Well, this is just x to the power of negative 2 means 1 over x squared. Actually, with minus 1 here, so it's minus 1 over x squared. Same sort of thing with this, 4 over 3x to the power of 4. It's only the x term that is to the power of 4. So when I write this, rewrite this in index form, it's y equals 4 thirds, and it's the x only that's to the power of negative 4. And now we can differentiate that, dy by dx. So we multiply through by the power minus 4. Now, 4 thirds times minus 4 is just minus 16 thirds. And x, we're going to reduce this power by 1. So when I take 1 away from minus 4, I get minus 5. And again, let's put that back in fraction form. Again, look, it's the x, it's the power of minus 5. So I can think of that as 1 over x to the 5. But when I have minus 16 over 3, and I want the over x to the 5, so I can put that x to the 5 on the denominator of the fraction.